Unit 3C, Lesson 4. In this lesson, we're going to discuss some more properties of logarithms so that we can expand, break logarithms apart, condense, rewrite logarithms as one. Then we're going to talk about the change of base formula at the end of the lesson, which allows us to approximate the value for logarithms that have a different base other than e or 10. The properties we are going to discuss and use in this lesson are the product rule, quotient rule, power rule, and change of base rule. We've already talked about the power rule in the previous lesson. The rule at the bottom, the equality rule, is pretty straightforward. If we have two logarithms with the same base, then the expressions on each side must be equal to each other. So the product rule says if we have a log with base a, and then we have two factors being multiplied inside our expression, we can break that apart using addition. So we would rewrite it as log base a of our first factor plus log base a of the second factor. So if you have a product, you're multiplying two factors within a logarithm, you break it apart using addition. Similar idea for the quotient rule. If we have a log base a, now we have two factors that are being divided. This time we break them apart using subtraction. So if we're multiplying, break it apart using addition. If you're dividing, break it apart using subtraction. Power rule we discussed in the last lesson. If we have a value raised to a power, we can bring that power down as a coefficient. And then the last one, the change of base rule, which allows us to approximate the value of any logarithm, any base other than e or 10. Then you have to remember the expression of the original logarithm goes to the numerator. The base of the original logarithm becomes the expression in the denominator. The base we can rewrite it as, which is represented by b right now. We could use the natural log, so base e, or the common log, base 10, to rewrite this, because then we could use our calculators to get that approximation. The first example we're going to go through is expanding a logarithm. So we have a single logarithm. We want to break this apart using those rules we just talked about, the product, quotient, and power rules. When expanding a logarithm, there's this little acronym I use to remember kind of a pattern on what I should try to do first. So first I'm going to look and see if there's any division. Then I'm going to look and see if there's any multiplication. And then last I'm going to see if there's any exponents. That's going to give me the order in which I should try to expand this logarithm. So we have log base 4 of 3x to the 5th divided by y. I see we have division going on within our expression. So I'm going to apply the quotient rule first. And the quotient rule tells us if we have two factors being divided, we can break this apart using subtraction. After applying that quotient rule, now we have the expression expanded in the form log base 4 of 3x to the 5th minus log base 4 of y. Now I want to look in both of these expressions to see if there's any multiplication going on. In the first expression, the first logarithm, I see we have 3 times x to the 5th. So now I'm going to expand, break this first logarithm up using the product rule. After applying the product rule, which tells us we can expand this using addition, now we get log base 4 of 3 plus log base 4 of x to the 5th minus log base 4 of y. The last thing we want to look at is to see if there's any exponents so that we can apply the power rule. Looking at the second logarithm, we have x to the 5th. Using the power rule, we can bring that exponent down as a coefficient. After applying the power rule, now we have our final expansion for this logarithm. We get log base 4 of 3 plus 5 times log base 4 of x minus log base 4 of y. The reason it's sometimes useful to expand a logarithm is, let's say we were trying to isolate x by itself, solve for that value of x. If we can break it apart, now we can see x is getting closer to being isolated by itself. Next step would be to move these other logarithms to the other side of the equation, and then go through a few more steps to isolate x. Example 2, now we're going to condense a logarithm, rewrite this expression as one logarithm. So we have 3 times the natural log of x minus the natural log of 2 plus the natural log of y. We can condense this logarithm as long as we have the same base on our logarithm. If this is the natural log, we know all of them are base e, so we can combine this into one. The general process for condensing a logarithm, we're going to go in the reverse order that we did when expanding a logarithm. First, I'm going to look and see if there's any exponents or if I could apply that power rule to create an exponent, then we're going to look at multiplication or division. These two are going to occur at the same time. The one we apply first is going from left to right. So as we're going from left to right, if we see subtraction first, we can apply the quotient property, create a division problem. If we're going from left to right and we see addition first, then we're going to use the product property, which means we're going to create multiplication. So looking at all three of these expressions, all three of these logarithms, I want to see if I can apply the power rule, create an exponent. So I'm looking to see if any of these have a coefficient. Looking at the first term, we have a coefficient of 3. So the power rule says I can create that and move it to become an exponent. After applying that power rule, now we have the natural log of x cubed minus the natural log of 2 plus the natural log of y. Next, going left to right, I want to see if I can apply that product rule or quotient rule. The first operation I see from going left to right is subtraction. So we have to use the quotient rule, which means we're going to create a division of x cubed and 2. After applying that quotient rule, we get the natural log of x cubed divided by 2 plus the natural log of y. Now the last thing we have to apply is the product rule, because we can see we have addition of these two logarithms, so we can create and use the product rule to multiply those two expressions together. After applying that product rule, we get the natural log of x cubed over 2 times y, which we can simplify, rewrite as the natural log of x cubed times y, all divided by 2. So condensing a logarithm, first you want to see if you can apply the power rule. Then you want to look and see if you can apply the quotient or product rules, going left to right, seeing whichever one occurs first between addition and subtraction. The last thing we need to discuss in this lesson is the change of base formula, which allows us to approximate the value for any logarithm with any base. So the first one we have is log base 4 of 7. Using the change of base formula, we're going to rewrite this using the common log with the base 10 or the natural log with base e, because we have the common log and natural log on our calculators that we can then use to get that approximation. For this first one, I'm going to use the natural log. So the change of base formula says I can take the natural log of the value of my first expression, which was 7, divided by the natural log of the base of the first logarithm, which was 4. So now I just have to take the natural log of 7 divided by the natural log of 4 using a calculator. And when you plug that into your calculator, you get approximately 1.404. When finding the values using the change of base, let's make sure we go to at least 3 decimal places for that approximation. Now for the second example, we have log base 2 of 17. We want to use the change of base formula to find the value, the approximate value of this logarithm as well. This time I'm going to use the common log. So if we have the common log, that's a log with base 10, we're going to take the log of 17 divided by the log of 2. Remember, whatever our original base was for the logarithm, that's going to be in the denominator of the fraction. Now we can just use the calculator to get this approximate value. And the approximate value you get is 4.087. So let's say in this last example, instead of using the common log, I used the natural log like I did in the first example. So I would have the natural log of 17 divided by the natural log of 2, which if you plug that approximate value in, if you calculate that, you get approximately 4.087. So it does not matter if you use the common log or the natural log. Just make sure if you're using the common log, you're using the common log in the numerator and denominator. If you're using the natural log, make sure you're using the natural log in the numerator and the denominator. In this lesson, we talked about a few more properties of logarithms that we can use to expand and condense logarithmic expressions. We also talked about the change of base formula, which we use to get the approximate value for logarithms with a base other than e or 10.